In section 4.4, we're going to be looking at proportional and non-proportional situations. The essential question of this section is, how can you distinguish between proportional and non-proportional relationships? Your objectives in this section will be to learn to distinguish between proportional and non-proportional relationships when graphed, to learn to distinguish between proportional and non-proportional relationships in equation format, to distinguish between proportional and non-proportional relationships in table format, and then to learn to compare or contrast proportional and non-proportional relationships. Distinguish between proportional and non-proportional situations using a graph. If a relationship is nonlinear, it is non-proportional. If it is linear, it may be either proportional or non-proportional. When the graph of the linear relationship contains the origin, the relationship is proportional. So at the very beginning of this passage, it tells us that if a relationship is nonlinear, meaning that it is not a straight line, it has either a crook or a curve or a bend in what looks to be an otherwise straight line, then it was going to be something that is non-proportional. But if it is linear, if it is indeed a straight line, it can either be one of two things. It can either be proportional or non-proportional. And to be able to determine the difference between the two is that if it is a linear straight line, then it goes through the origin, then it is going to be proportional. If it does not go through the origin, then it is going to be non-proportional. In example 1, we're asked to determine if each of the following graphs represents a proportional or non-proportional relationship. So in graph number 1, what we see is a blue line that is indeed going to be linear. So this is a linear relationship. And then the next thing that we want to be able to determine is if this line is actually proportional or non-proportional. So in looking at it, what you'll see is that this line is not crossing through the origin here at 0, 0. So it's actually starting at 1, or it's crossing the x-axis. When x is 0, it's crossing the y-axis at y equals 1. So this is what we would call a non-proportional relationship. So this is a linear non-proportional relationship. Now in number 2, what we see is a graph of another line, and it is absolutely straight. So this is going to be a linear relationship. And what we also see is that this line is actually crossing through the origin this time. It's crossing where the x and y axes meet. So this is going to be a proportional relationship as well. So in our first example, we have a linear non-proportional relationship, and then in our second, we have a linear proportional relationship. Distinguish between proportional and non-proportional situations using an equation. If an equation is not a linear equation, it represents a non-proportional relationship. A linear equation of the form y equals mx plus b may represent either a proportional when b is equal to 0 or non-proportional when b is not equal to 0 relationship. So in essence, what we see is that when we have something that is not a linear equation, it's absolutely going to be non-proportional. If we have something that is a linear equation that's in the format of y equals mx plus b, which is our slope-intercept form, then it can either be one of two things. It can be proportional if we have a b value that equals 0 in that equation, which is our b equals our y-intercept, or if that b value is not there at all in the equation, then it's going to be proportional. And non-proportional when we do have a b value and that b value is not equal to 0. In example 2, we're asked to determine if each of the following equations represents a proportional or non-proportional relationship. So what we're looking here is that we have kind of these equations following a generalized format of y equals mx plus b. So we have one of our variables of our ordered pair over here to the left, it's equal to our slope times the second variable or another variable of our ordered pair plus some number. B is always going to be some constant. It's not going to have any variable associated with it. So it's going to be just a regular number here. So what's one thing to note about all these equations is that we don't necessarily have to have these exact letters like y and x in our equation, or variables y and x in our equation. We can have other variables, so it doesn't necessarily have to follow y and x in that equation. It can be other variables as well. So in the first one, what we have here is d is equal to 65t. This d is sort of like the y in our y equals mx plus b equation. We have our equal sign. We have 65, which is acting as like our slope, and then t is acting as though it's like our x. So when you look at this, we might have the ordered pair instead of x and y, we might have the ordered pair of something like t and d. And so when you look at this particular equation, it's missing that plus b part. Okay, so we could very easily rewrite this equation as d equals 65t, and if we wanted to put in that y-intercept or that b part, we would say plus 0 here. And in which case, if we have something plus 0, that means that it's going to be crossing the y-axis at its origin 0, 0. So this is going to be what we would consider as a proportional relationship. Now, in number 2, what we see is an equation, excuse me, p equals 0.1 s plus 2000, or p equals 1/10 s plus 2000. And if we were to look at how this follows kind of this generalized format of y equals mx plus b, the p could be representing the y. We have our equals. The 1/10, that could be representing our slope of m. The s could be our x. We have our plus sign, and then the 2000 could be representing our y-intercept b. So this follows the exact kind of format of y equals mx plus b, kind of in more general terms, because it does have different variables for y and x with p and s respectively. So this is actually going to be a linear equation because it does follow a linear format of y equals mx plus b, or that linear equation there. And so what we can say is that this is also going to be linear, but it is going to be non-proportional because of this b value here, this y-intercept. So we look at that, and we see that this line is actually crossing the y-axis at y equals 2000. So it doesn't cross through the origin, so this is going to be a linear non-proportional relationship. Now in our next equation, what we see here is that it's kind of rearranged here. We have our variable, we have a variable here to the left equals, and then we have a number minus 3p, which is a variable term. So what we might want to do in this problem is we want to take this and rearrange things where we have n equals, say, a negative 3p plus 450, and I do that in order to try to see if I can rearrange it into this format of y equals mx plus b, or this linear equation here. So I'm going to say that the n is very similar to the y. We have an equals, we have a negative 3, which can act as our m. The p can be in place of our x, and then we have plus 450, and that can be in place of our b here. So this is actually going to be a linear equation, and since it is not crossing through the origin because we do have a b value other than 0, we are going to label this as non-proportional. Now, in our fourth and final equation here, we have 36 is equal to 12d. So we start out with a constant on the left-hand side, and we really need to have a variable on our left-hand side. So we would need to get this variable term 12d over here, and then on the left-hand side, we would need to get our 36 on the right-hand side. So if 36 is equal to 12d, then 12d is also going to be equal to 36. So I can rewrite this as 12d equals 36. Now, when you look at this, we have a coefficient here in front of this variable d. So what I need to do here is I need to get rid of this coefficient so that I get just a single variable. Let's try to get say something like y by itself. And so what we're going to do here is if I had 12d, that means 12 times d. So to break that apart, I'm going to divide this by 12. Now what I do to one side of an equals, I must do to the other. So I'm going to divide this side by 12 also. When I take 12d divided by 12, the 12s are going to cancel. It's going to leave me with d equals. And when I take 36 divided by 12, I'm going to get 3. Now, the d is acting sort of like our y, and we have an equals here. We simply just don't have another term here with our slope and the other variable of our point. And so what we have here is that y equals b. We don't have this this mx term here on the right hand side. So when we have d equals 3, that means that that's a line that's going to be passing through the y-axis at 3. So if that's the case, this is a linear equation, and it is going to be something that we would classify as non-proportional. Distinguish between proportional and non-proportional situations using a table. So if there is not a constant rate of change in the data displayed in the table, then the table represents a nonlinear, non-proportional relationship. A linear relationship represented by a table is a proportional relationship when the quotient of each pair of numbers is constant. Otherwise, the linear relationship is non-proportional. So in this passage, they're telling us on how we determine whether something is proportional or non-proportional by use of a table. So when we look at, say, numbers that are in a table, they can either be one of two things. They can be either nonlinear or they can be linear. If they are nonlinear, then they're absolutely going to be non-proportional at the same time. However, if you have numbers in a table that are demonstrating a constant rate of change, and that means they are going to be linear. Now, when they're linear, they can be either one of two things. They can be proportional or they can be non-proportional. They are proportional if the y to x values of each individual ordered pair or each individual point in that table is the same. If they are not the same, those y to x values, then that linear relationship is going to be non-proportional. In example 3, we're asked to determine if the linear relationship represented by each table is a proportional or non-proportional relationship. So in this particular problem, we're given a key bit of information. It is that we have linear relationships. And so we don't have to go through and determine if the rate of change from one ordered pair to the next is going to be constant. And so we're not going to have the nonlinear, non-proportional abilities here in these particular tables. So what we are going to look for, though, is we're going to look to see if these linear relationships that we have in these tables are going to be proportional or non-proportional. And the way that we determine that, after we've already determined if it is indeed linear or non-linear, is that we're going to compare the y to x values. So in this first problem, or in this first ordered pair here, I'm going to take 30 and I'm going to divide it by 2. Now when I take 30 divided by 2, that is going to give me 15. So then I'm going to compare the next y to x value, which is going to be 90 divided by 8. And you may not really know this off the top of your head, so what you may need to do is go over to the side and take 90 divided by 8. Now when I take 90 divided by 8, I'll see that 8 goes into 9 one time. I'm going to get 1 down here, and I'm going to bring down my 0. Now 8 will go into 10 one time. So 8 times 1, that gives me 8. 10 minus 8 will give me 2. Now when I go to read this, I'm going to start at the top. I'm going to say this is 11 and 2/8, which I can then simplify down to 11 and 1/4. So I see that 90 divided by 8 is going to be 11 and 1/4. Now in my last y to x value, I'm going to have 150 over 14. And so if I were to divide that, I would go over here to the side somewhere. I would take 150 divide by 14. I would see that 14 goes into 15 one time with 1 left over. I bring down my 0, and then I see 14 goes into 10 0 times. So I would have 10 minus 0, and I would get 10. So the way I would read this is 10 and 10/14, which I can then simplify down to be 10 and 5/7. Now what you'll see is that each one of the y to x values are changing here. They're not constant. So this is what we would classify as a non-proportional relationship. And that would be for the first one there. Now for the second one, we already know that this is linear because we are told in our directions that it is, so we know the rates of change are consistent between each one of the ordered pairs. So now what we're going to do is we are going to compare their y to x values. So in the first one, we're going to say that's 1 over 5, and that's a simplified fraction. There's nothing more for me to do there. Now in the second one, we're comparing the 8 to the 40. Now if you see this fraction, you have 8 and 40, they're both going to be divisible by 8. So I can divide numerator and denominator by 8. I'm going to say 8 divided by 8 is 1, 40 divided by 8 is 5. So I once again get 1/5. And then in the very last one, I'm going to be comparing the y value, which is 13, to the x value, which is 65. And if you look at this, I believe 13 can go in, I guess we can divide both 1365 by 13. So I would divide the numerator by 13 and divide the denominator by 13. So 13 divided by 13 gives me 1. When I take 65 divided by 13, that's going to, I can find out that's going to be 5, because once I take 13 times 5, I am indeed going to get 65. So if you look at this, all of our y to x values are the same, they're constant. So this is going to be what we call a proportional relationship. Comparing proportional and non-proportional situations. You can use what you have learned about proportional and non-proportional relationships to compare similar real-world situations that are given using different representations. In example 4, we're asked to compare and contrast the following two situations. So our first situation is Test Prep Center A. It says the cost for Test Prep Center A is given by C equals 20H, where C is the cost in dollars and H is the number of hours you attend. Then we're given a second situation where we have Test Prep Center B. Test Prep Center B charges $25 per hour to attend, but you have a $100 coupon that you can use to reduce the cost. So when we look at these two scenarios that are given to us here, we what kind of stands out is that we might want to use the equation method for being able to compare and contrast these two situations or options. So in the very first one, for A, we're given the equation that C, the cost, is going to be equal to 20 times H, the hours. And then in Test Prep Center B, or in option B, we're given that they charge $25 per hour to attend, but they also give a $100 coupon that will reduce the cost. So we still have a cost here with this one. So C is going to represent our cost. It's going to be equal to $25 times how many ever hours we attend, because each hour is costing $25. And then we also have this coupon that takes off $100. So we're going to say minus 100. So looking at these two equations and kind of comparing them to see if they're linear or nonlinear, or proportional or non-proportional. So what we're going to do here is we're going to say that we have our equation y equals mx plus b. We're going to kind of compare them with that linear equation. So in the first one, in option A, C is going to be very much like our y value. We have our equals here. The 20 is going to be like our slope, and then the h is going to be like our x here. Now what you will notice is with this equation that we don't have a plus or minus number here at the end. So they're not giving us a y-intercept. So If we don't have a y-intercept, this is going to be one of those situations where the b value is equal to 0. And when the b value of a linear equation is equal to 0, then what we are going to have is a proportional relationship. So this is actually proportional, and it is linear as well. Now, in option B, we formed this equation that C is the cost is going to be equal to $25 times how many hours of attendance at this test prep center, and then we are going to take off the $100. So this C value is going to be very much like our Y value. This equals is going to be the same here as our equals here. We have our M, which is going to be represented by the 25 in this equation for the $25 per hour. Our H is going to be very similar to our X. And then we have a minus 100 here, which is plus B, or which is our y-intercept. So when we look at this, this is also going to be a linear equation. However, it is going to be non-proportional because this particular graph of this line is not going to get this spelled correctly, non-proportional. This equation is not going to go through the origin. It's going to cross the y-axis at negative 100. So this is going to be a non-proportional. So comparing them, they're both linear equations, but contrasting them, they're both going to be different in that test center A is going to be proportional, whereas test center B is going to be a non-proportional linear equation. Now, another way that we can compare them is by cost. And so what you would want to do here is you would want to try to find, say, a break-even point of where test prep center A and test prep center B are going to be exactly the same cost. And so what we would say here is that the cost of test prep center A would be equal to the cost of test prep center B. Now, the cost of test prep center A was going to be the same as 20 times H, or $20 times each hour of attendance. Now, the cost for test prep center B was going to be $25 per hour, and then we were going to take, we had that $100 coupon in which we would take things away. Now, from here, if we solve this equation, then we're going to find our break-even point on where both options are going to be equally as good. So what I'm going to do here is I'm going to try to get all my variable terms to one side or the other. So we already have a variable term 20h on the left-hand side of my equals. So I need to get this 25h over there with it. So since it's a positive 25h, we would subtract 25h from this side. Now what we do to one side of an equal sign or an equation, we do to the other side as well. So I'm going to be taking 20h minus 25h, which is going to give me a negative 5h. And that's going to be equal to, now on the other side, the 25h's are just going to simply cancel out. And that's going to leave me with only that negative 100 remaining. So what I would do here to solve for h, or the number of hours in which both options are going to be equally as good or the same cost, I would get rid of this negative 5 here. And I would do that by dividing that negative 5h by negative 5. Now what we do to one side of an equation, we must do to the other. So I'm going to divide negative 100 by negative 5 as well. When I take a negative 5h divided by negative 5, the negative 5's cancel, and that leaves me with h equaling negative 100 divided by negative 5, which is going to be 20. So what we find here is that at 20 hours, test prep center A, test prep center B are going to be exactly the same cost. Now, when the hours are either less than that, say 19 hours, or when those hours are greater than 20, say at 21 hours, one of them is going to be more expensive or less expensive than the other one. So what we need to do there is try to find out which one is going to be a better option, say when it's less than 20 hours and when it's more than 20 hours. So what we would do here is we would say let, say, h equal 19. And then what I'm going to do is I'm going to take each one of the expressions that the cost is representing, and I'm going to plug in that value of h to compare them. So we're going to let h equal 20, or let h equal 19. And then I'm going to say 20 times 19 for option A. And then I'm going to say 25 times 19 minus 100 for option B. Now if I take 20 times 19, that's going to give me exactly 380. And that's going to be the cost for 19 hours of instruction or test prep at Center A. Now if I take 25 times 19, that's going to give me 475. We still have that minus $100 coupon. And if I take 475 minus 100, I'm going to get $375. So when we have 19 hours of test prep, the better option is going to be Test Prep Center B. It's going to be less expensive. Now, what happens when we have more than 20 hours? So we're going to say let H equal 21. And then I'm going to do the same thing, but this time I'm going to replace the H in each one of the cost expressions with 21. So we have 20 times 21, and then we have 25 times 21 minus 100. So when I take 20 times 21, that is going to give me exactly $420. So after 21 hours, at 21 hours of test prep and instruction, it's going to cost $420 at Center A. Now, for Center B's cost, we're going to be taking 25 times 21, which is 525, minus that $100 coupon, and we're going to see that that's going to be $425. So at this point, this is A on our left, this is Test Prep Center B on our right. So we see that 420 is going to be less than 425. So in comparing these two, we see that after 20 hours, if you're going to be doing 20 hours of Test Prep Center A, Test Prep Center B are going to be exactly the same cost. Now at 19 hours or actually less than 20 hours, Test Prep Center B is going to be the lower cost option here. All right. And then when we have more than 20 hours, we see that Test Prep Center A is going to be the better option. So depending upon how much test prep a person would need, they could then compare and contrast which one would be the better cost alternative based on that.